Okay, we're almost to the end here. In example 5, we have cotangent of theta equals -1. Like the last example, I don't like it when the final expression of the answer has a secondary trig function, so I'm going to reciprocate both sides. The reciprocal of cotangent is tangent, theta, and the reciprocal of -1 is just turning it upside down, so it's actually still -1. Okay, well, tangent is negative in quadrants 2 and 4, so I'm going to draw a little mini axes here. And here's an arbitrary angle in quadrant 2. Here's an arbitrary angle in quadrant 4. And if I think, or look at the chart over there and say, what reference angle has a tangent that's 1? The answer is 45. So I'm going to put 45 right here in the reference angle position. And I'm also going to put it right here in the other reference angle position. And I'm going to come up with my two angles. The first angle is going to be 135. And the next angle is going to be the whole circle except for 45, which is 315. So I'm going to write 135 and 315, assuming that the question wanted the specific degree answers from 0 to 360. Now, if they wanted the specific radian answers from 0 to 2 pi, I would just say 3 pi over 4 and 7 pi over 4. Quick, easy conversion. Okay, now I thought for this one, for all degree solutions, I think I'm going to show you the graphing calculator. I'm going to drag this over here, and I'm going to go to my y equals screen, and I'm going to put in tan x, and I'm going to come down here, and I'm going to put in -1. And I'm actually going to do this in degree mode. I usually don't do this, but I think it's just easier for demonstration purposes if I do. So my window, I'm going to go from negative 360 to positive 360. And I'm going to go by 90s, a nice clean interval. And I'm going to go from -4 to 4 by 1s. And if I press graph, I'm going to see a series of tangent graphs, which look like increasing wiggles. And I'm also going to see a line, a horizontal line down at -1. So let's take a look if that's actually what I get. Now, if I just do one of those intersections, I should get an answer of 135. The first positive intersection that I get should be at 135. Let's see. Second, trace, 5. Let's go to this first positive intersection. Enter, enter, enter. And it tells me the intersection is 135, which is awesome. Now the real question is, how far away are those other intersections from the home base one? Well, the period of tangent is just 180, and I think these are all 180 away from each other. They're all equally spaced or equidistant. So I think the best way to express the all solutions question would be x equals home base of 135 plus 180n, where n is an element of the integers. And if I had to write this in radians, if that's what the question asked, I could just say x is equal to 3 pi over 4 plus pi n, where n is an element of the integers. Okay, in our final example, we are going to solve the equation 8 secant theta equals -16. I'll start by isolating and dividing both sides by 8, and I get secant of theta is equal to -2. Secant is secondary, so I prefer in this instance to reciprocate, and the reciprocal of secant is cosine, and the reciprocal of -2 is just -1/2. And this isn't bad. This is going to be some benchmark angles where cosine is negative, so I'm going to draw a little mini set of axes here. And I know that cosine is negative in quadrants 2 and 3 with a reference angle of 60. So I'm going to put a 60 in the reference angle position and another 60 in this reference angle position. And the first answer is going to be 120. And the second answer is going to be 180 plus 60, or 240. Now, if we were asked to do this in radians, we would just convert, which would be 2 pi over 3, 4 pi over 3. And now we've got this situation over here with the whole find all the degree solutions. Now, I could call up the graph, but what I want you to realize is that this might be a little shortcut that could help you. The distance between these two answers, if this is one answer and this is another answer, the distance between those two answers is not the same as it is going back all the way around again. This distance is much shorter than this distance. Whenever that happens, you've got to write each answer separately. So what we have to do in this case is say x equals 120 and all of its coterminal equivalents, which are going to be plus 360n, where n is an element of the integers. Now, conversely, the second answer was 240, and now we need all of its coterminal equivalents, which would be plus 360n. N is an element of the integers. Now, if we wanted the radians, we would just quickly convert this. So I'm going to go fast through this. This is going to be 4 pi over 3 plus 2 pi n. N is an element of the integers. And then this guy is going to be x equals 2 pi over 3 plus 2 pi n. N is an element of the integers. Cool. I just want to go back to this concept real quick for just 1 second. Believe me, I'm itching to be done with this problem as much as you are, but I just want to show you one thing. Let's say we had some axes like this, and we had an answer here in quadrant 1, and we had an answer here in quadrant 3. And let's say the reference angle was 45. Now, this time, the two answers are equally spaced. The distance it is to go from here to here is the same as the distance to go back to here. So you wouldn't say 45 plus 360n and then 225 plus 360n. We could say 145 plus 180, and then we add another 180 to get this, and go another 180 to get this. So if ever your answers are equally spaced, you can express the answer with one equation, or one expression. One expression. But in this case, because they're not equally spaced, we need two expressions.